Hello guys, I am Ashish Negi. In this video, I'm going to talk about MergeSort. MergeSort is a divide and conquer technique in which we divide the given elements into two halves and then we further divide the divided elements till we reach a condition where the length of the given elements is 1. What I mean by that is, let's consider this example. Uh, the length of this array is 8. We divide it into two halves as 8 divided by 2 is 4. Length of this half is 4 and this half is 4. We further divide this array into two halves with length 2 and then we further divide it into with length 1. So as we reach the condition where the length of the given elements is 1, then we start sorting and then merging them. What I mean by that is, consider this. 6, 5, as 5 is smaller than 6, 5 will come first. 1, 2, 7, 9, 3, 4. And then we compare these two arrays. For this we need a counter. As the length of elements was 1, it was easy. But when we are comparing two arrays, we need a counter. Let's call this A, let's call this B. So counter A small a, counter B small b. They start with 0. Okay. So first we compare A0, like A0 and B0. So A0 is 5 and B0 is 1. So 1 is smaller than 5, right? So 1 will come first. And then we increase the counter of B. So B plus equals to 1. So B is 1 now. That means the counter is pointing at 2 right now for B. So then we compare 2 with 5. 2 is smaller than 5, so 2 will come over here. As this array is completely destroyed, like now we don't need this, so we add the remaining elements 5 and 6 as they are, because they are already sorted. The same thing we'll do with 7, 9 and 3, 4, as 3, 4 are smaller than 7 and 9. They will just come over here, 7, 9. Now when we want to combine these two, again we'll have a counter I and j. We'll compare 1 with 3. 1 is smaller than 3, so 1 will come. I plus plus, so I is now 1. It's pointing over here. We'll compare 3 with 2. 2 is smaller than 3, so 2 will come. Now I is pointing over here. We'll compare 5 with 3. 5 is smaller. 5 is greater than 3, so 3 will come first. Now the counter will go over here. 5 and 4. 4 is smaller than 5. 4 will come first. And pointer will go over here. Then remaining will sort as 5, 6, 7 and 9. So this is what the algorithm of MergeSort states. Next we'll see the code. Uh, I will write the code. Just wait. So my code is going to be in language Python 3. So let's go ahead with it. Definition. We'll call it MergeSort and we need to pass the list of elements. So let's call those as array. Then we need to divide the given elements till the length of the elements is 1. So our first condition will be if length of array is greater than 1. If it's not, then we don't need to divide it. Okay. Uh, we'll find the middle element first. The middle is equals to the array divided by 2. Okay. We'll take as we are dividing it into two halves, so let's call the two halves as left and right. So left is equals to array from 0 till the middle element. Okay. The middle element is not included in this one. It will be included in right. Right is equals to array from middle to the end of the array. Okay. Then now we need to call the merge sort on these two arrays, like merge sort on left and merge sort on right, because we need to further divide it, right? So merge sort left, merge sort right. Okay. Uh, Now we take those counters which I was talking about before, like I, j, k is equals to 0. I is for left, j is for right, and k is for storing our result in the same array, this array, arr. Okay, so we need to write conditions before we start comparing. So the condition must be while I is smaller than length of left and j is smaller than length of right, because I cannot be greater than length of left. Like what I mean by this is uh, I cannot be more than 4, right? I should be smaller than 4, or it will give index out of range error. Okay, so where is it? So we start writing our conditions while I is I is smaller than length of left and k is smaller than length of right. Okay, and now we compare. If left of I smaller than right of j, that means the element in left is smaller than element in right. So we'll store the element in left in our main array, main answer. Array of k is equals to left of I, okay, and then we have to increase I equals to 1. We also need to increase k, but we'll do it later. Else the else condition means that right is smaller, so we store right. Array of k equals to right of j. Okay, then we increment j, and now we increment k because we need to increment k anyhow. So this is the condition till the length of the array is not over. For example, uh, in this case, which case, 1, 2, okay, this case. Okay, let's take this one. Okay, we took 3 and we took 4, so this array is completely over. Now we need to add these two, but our condition is like as j is should be smaller than 2. Now when we took 3, j became 1. When we took 4, j became 2. Now we are out of that loop, so we need to write code for these remaining elements. We cannot leave these. So for that we write. So we also don't know that which array is gonna finish. So we will write code for both of them while I is smaller than length of left. We add these. Array of k is equals to left of I. Then we increment I plus equals to 1, k plus equals to 1. Okay. Then we copy this as we need to write it for right as well. Okay. So So j, right, j, right, increment j, sorry j. Mm, we're done. Let's see if it works. Let's take 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Let's pass it to MergeSort. Okay, we have an error. Let's check what there is. Oh, sorry, I wrote small a. Where is it? Length of array is greater than 1. Oh, the first beginning. Okay. Now the answer is stored in 8 sub. Okay. I also wanted to add that the time complexity of MergeSort is n log n, and it is a stable sort. So it is used when you need stable sorting, and also we need to take care that we have space because MergeSort needs O of n's auxiliary space to perform its sorting as it stack ups all the space. So you should always remember that. And thanks for watching this video.